Hey guys, this is Lee, and it's been a while since I made videos for my YouTube channel. I've been busy with a lot of other things and I didn't abandon the channel. It's still running with my old videos, and now I decided to revive my channel with new videos, and this will be one of the revival videos, but there will be more videos coming soon. And yeah, so today, what do I have here today? I was taking a walk at the university dump yard to see if I can salvage some discarded hardware components, and apparently I happened to find one of these modules, and this looked like a ATX power supply, and I thought maybe I could use ATX power supply to build a bench power supply for the lab and so on. And then what I apparently noticed was this is not a normal ATX power supply, but instead it's a dual module power supply. It looks like there seems to be two mains connection, and also looks like in twin identical modules, but we'll see later. But first we take a look at what the description on the module has to say. So here we have the total wattage of this module is a 460 watts. It looks quite big for 460 watts, but as we already know, it incorporates two different modules. So this ATX power supply is supposed to be a power supply for running servers. So why do we have two modules here? It's because to provide uninterrupted power supply for the servers. The servers need to run 24/7, and they need to have as much as redundancy as possible, and even in the power supply modules. So here we have two power supply modules which are identical, and the power supply tries to power the main system from both these modules. If one of them fails, then it switches to the other one, and it's supposed to keep the server running 24/7. So apparently this module seems to have failed to do that job. Apparently both the modules failed, I'm not really sure. So what I did was I tried to completely dismantle it to see how exactly this module works. So during this video I will take you through this journey of what I did with this module. So fancy pantsy, these things slide off easily out of these modules, and what you can see are individual power supply modules, and these modules look very similar to the one that we saw before, and it also has the same 460 watts rating. So as you already know, they don't combine together to provide a higher wattage, but simply the same specification two times, and one of them is a redundant system. So pulling out both the modules out of the main system, we have these modules. I keep them aside for a while, and now what you see inside is the two interfaces where the PCB, which looks like a card interface, slides in, the module slides into one of those sockets, and both the modules slide into one of these sockets here and try to combine. So let's take a look at the PC. It's all dismantled, so just to make this video quicker, I've done my homework and tried to remove everything and keep everything prepared. So I tried to pull this PCB off to take a look at what exactly this PCB module was supposed to do or does. So if you can see, there's not a lot of active components, a lot of passives down here, capacitors, resistors, and some jumpers and connectors and so on, and two interfaces to incorporate these two modules. And there was also another add-on card which was lying on the side. So this is was the module, which has a buzzer and also a connector to connect an input for a switch, and this module slides in like here. So I'm not really sure the job of this. There's, again, as I said, there are not a lot of active components, mostly passive, so I think it could be some kind of like a delay circuit or a buzzer circuit, where once the board receives some kind of external input and tries to switch the power supply between one of them. I'm not really sure what this exactly does. But going to the main point of this video and discussion, so I wanted to find out how I could use these modules, but there's no pin outs for these modules, so I have absolutely no idea, or I had absolutely no idea what all these pins and lines on this module meant to be. Is it supposed to be, which of them is supposed to be ground, which of them is supposed to be a 12-volt supply? I have absolutely no idea, so I had to do some kind of reverse engineering to get to know the pins before I could do anything with the modules. So how did I do that? Going back to the PCB, it was quite easy. What we know is this interface here is a standard 24-pin ATX power supply interface, so we definitely know what each of these pins mean, and then by tracing the color of the cable onto the PCB, we can already see the PCB is well labeled. I tried to zoom to see, I don't know if you could see the labels on the PCB. Yeah, just as an information, so each of the bunch of cables connected together, they have a label on the PCB or a silk screen on the PCB, so we know what each of these connections are supposed to mean. So we know, for example, tracing this bunch of yellow lines here is a 12 volts line, and when I flip the PCB, then I know this particular track is supposed to be a 12 volts line. And tracing back, I use my multimeter and the connectivity check to trace the final connection from this point onto the point onto one of these 86 pin connector here. So this is what I did. I tried to track each of the lines onto the PCB from the cable to the interface, and then I have a schematic. I will show you a pin out that I reverse engineered from the PCB. Going back to the point, if you find one of these modules and if you want to salvage the useful components from this module, you know you have the pin outs. So what I did, as I already said, we know the 24 pin interface, 24 pin ATX pin out, and one of these pins is supposed to be power supply on signal. So it's a signal that you tell your power supply module by connecting it to ground, and then your power supply module knows that it's supposed to turn on. So I tried to find the PS on line, trace back the PS on line on this module, and then connect a cable shorting the PS on to the ground. So this is basically telling the power supply module that it's been requested to turn on. So what I will do now is I try to connect this, power this module up and see if it works. Okay, as you can hear, the module is turned on, and you can see the green light here turned on, and the fans are spinning really loud. And now it's time to check the output lines of this module. So I have connected my multimeter, set it into the DC voltage mode, and now I know from this pin out the line from 22 to 24 is supposed to be a plus 3.3 volts, which is supposed to be this. Okay, so this point should be 3.3 volts. As you can see, it's about 3.4, not loaded, so on load voltage should be regulated to 3.3. And then this is the ground line, and this is again the 12 volt line. So that's out of focus. So 12 volts line. So basically what I did was I salvaged the modules, and I tried to do the same for the other module as well, and I tried to connect the same or short the same cable, so this module works as well. So apparently I seem to have rescued two power supply modules which have an output of up to 460 watts. So what I'm gonna do with that, I'm not really sure. Probably one of them will be used to build a power supply, a bench power supply for my desk here. I don't have any bench power supply. And the other one I could use to build for my 3D printer that I'm planning to build. So this is again for future, but for now I have two power supplies that could be used for hobby grade work. Yes, so that's it for this video, and thank you for watching.